Section 6.1, the need for proof. Oftentimes our intuition will lead us to false conclusions. Consider the example questions and estimate your answer before going through the solution. So we're going to prove things because our intuition doesn't always tell us the correct answer. So a motorist drove 120 kilometers from Watrous to Saskatoon at a speed of 90 kilometers an hour. This sounds like my dad. Because of a snowstorm, the motorist made the return trip at 45 kilometers an hour. So what's their average trip? So a lot of people intuitively would go 90 plus 45, divide that by 2, and they would say, oh, they're going about 67.5. That's their average speed. However, you will remember that we need to look at distance, speed, and time. And those two things have a relationship, okay? Speed is distance divided by time. And so we need to use these relationships. So our total distance, he went 120 kilometers, and he did it twice. So he traveled, and I didn't even say it was a he, I just assumed, 240 kilometers. Okay, his total time is what we have to look at now. Well, let's see. If I do distance divided by speed, I will get time. If I go 120 kilometers in the first leg, and he did that in 90 kilometers an hour, so you can see that my units, this will give me hours. Okay, that's how much time it took him to do the first leg. The second leg was 120 kilometers as well, but he did it in 45 kilometers an hour. Okay, and I'll get hours. So this is like saying 4/3 hours. I just simplified this fraction, plus 8/3 hours. Okay, this has a common denominator. 8 plus 4 is 12. 12/3 is just 4 hours. I don't know why I have hours there. Okay. So now what I do to find his average speed is I go total distance divided by total time. So his average speed is equal to 240 kilometers for 4 hours. And that gives me actually 60 kilometers an hour, not 67.5. Okay? So our intuition was not correct. So we can't say things are true unless we prove them, unless we show them. And that's what this entire chapter is about, is proof. Okay, here's another one. 2 containers containing 1 liter of cola and the other a liter of milk are standing beside one another. A cup of cola is transferred to the milk container and thoroughly mixed in. A cup of the mixture is then transferred to the cola container. Is there more milk in the cola or more cola in the milk? Okay, so let's look at this. Intuitively, you should think about this. Which one do you think is more? So we have cola and we have milk. Okay, so we take a cup of cola out of here. We take a quarter of this and we put it in here and we mix it in. And then a cup of this then goes back in there. So is there more milk in cola? Is there more cola in here? Or is there more cola in milk? What do you think? Well, intuitively, I would think there is probably more cola in milk, is my intuition, but we'll see. Okay, at the start, in the cola container, we have 1,000 milliliters of cola and we have 0 milk. In the milk container, we have no cola and we have 1,000 milk. Okay, now we put 250 milliliters of cola into milk. So I take away 250, I'm left with 750. I haven't added any milk in this container yet. In this milk container, I have added 250 of cola and I still have 1,000 milliliters of milk. Okay, so now I take 250 out of this mixture and put it back in here. Okay, so what we're going to do here is I am going to say that I have to figure out what percentage is milk and cola here. I have 250 of milk. Of the total volume is 250 cola out of the whole volume is 12.50. So that's the same as saying 1/5 is cola. So now when I take 250 out, 1/5 of it is going to be cola and 1/5 of it is going to be milk. Okay? So if you think about 250 and divide that by 5, that's 50 milliliters. So what I'm taking out, 50 mils is going to be cola and 200 mils of milk. Okay, so I'm taking out 50 of cola, so that means I'm going to have 200 here, and I'm taking out I'm taking out 50 of cola and I'm taking 200 of milk, so then I'm left with 100 here. Okay, and now I'm adding 200 here, and I am adding a 50 here, so 800. So our intuition was wrong. There's actually equal amounts of milk in the cola and cola in the milk. There you go. Impress your friends with this party trick. Mix up their milk and their cola. Okay, you have an assignment to try for this section.